Hello and welcome. On the bench today I have a Pioneer A10. It's an integrated amplifier. It's broken apparently, so we're gonna fix it, or at least we're gonna try. It barely fits in the camera. This is a very simple amplifier. It's all analog inputs, no HDMI, no digital inputs, and you can just select the input, and it's a stereo amplifier, so no 5.1 Atmos or anything like that. It's the old-fashioned amplifier for people who likes to listen to stereo music. Nothing wrong with that. I purchased these on Facebook Marketplace for only £10 as non-working, so I was aware it was not working. When I took it home with this original box, I noticed on the box something which is a bit concerning. It says, return unrepaired. So out of curiosity I went back to the seller, just out of curiosity of course, I wasn't going to complain, I knew it was non-working, and he basically told me he bought it from someone else, he realized it wasn't working, he just wanted to recover the money, and he doesn't really know anything about this thing. So who knows what we're gonna find inside, but first thing first I would say we can try and power it up to see if it actually doesn't work, and then we'll open it, I guess, and we'll see what happens inside. So let me thank today's sponsor, PCBWay. Let's plug this up and see what it does. Now first thing first, let me say that this thing looks brand new. I mean, there's not a single scratch, the top is mint, and even the front panel I would say is mint. I mean, this looks like brand new, so I'm curious to see what's inside, but let's plug it up and see what it does. Now I'm going to my current limiter just in case there's a massive short inside. So let me give power to my current limiter, 3, 2, 1, go. Okay, I have nothing happening, and I have the standby LED is flashing. I think that's what the seller told me. Let me show you. So the LED is flashing, but I think it's actually sending me a message. This is an error message, because we have one long flash, two short, one long flash, and two short. So hopefully we can find the service manual of this thing and see what happens, because I think if I try and turn it on, yeah, nothing happens, and it keeps flashing this way, it doesn't change. So let's see if I can find the service manual and by any chance there's any information about this. Alright, I found the service manual and I think we have great news. Now this is where the protection circuit description is mentioned, and there is this mention here. When it comes to power protection, it says that if the power supply is automatically turned off after the power protection is detected, all key operations are prohibited. Power on is prohibited. It's like the Yamaha that I fixed some time ago, that after a power issue that was caused by a capacitor, I think, on that unit, the whole unit will refuse to power on. Basically says, well, I need to see an engineer. Yeah, I can't just allow the user to turn me on. Then it says, for turn on the power supply again, refer to 3, how to reset the prohibition of power on, shown below. And down below on here, on the left, we have the arrow messages. So that's the protect LED display specification. It's how the front LED flashes depending on the different errors. Like temporal protection, it's like continuous flashing, slow, quick flash. So it's on, off, on, off, on, off. If we had an overload, amp overload protection, so basically you're running it too hard, you would have long on, long off, long on, long off. For the power protection, I think is what we are seeing on the actual amplifier. So we have 2 short pulses and then we have a long one. So it's 2 short, flash, flash, and then a long one, which is what we were saying. So in theory, how do we reset this now? How to reset the prohibition of power on, I like this, translations. Press front key direct plus speaker B at the same time for 2 seconds or more continuously. The key prohibition mode after 111 amp failure is detected and 14 power protection is detected is released and the power supply is turned on. So by basically pressing direct and speaker B, holding on it for more than 2 seconds, it should turn on. Now whether it might shut down again, maybe there's an actual fault, but let's try. Alright, I'm still going through my current limiter. I don't know whether the current limiter is going to have enough power to charge the capacitors, but we'll see what happens. So let's apply power now, and this should be flashing. Yes, it's flashing as before. So I need to press direct and B at the same time, and we'll see what happens. Oh, it's turned on. Okay, it went down again with, I guess, the same error. 2 flashes, 1 long. So yeah, there is a power issue on this thing, but nothing horrible. I don't think my current limiter is showing an issue. Let me check. No, it's drawing 50 watts. Yeah, nothing really happens. It goes back to the fault condition without overloading my current limiter. So there is a fault with this thing, and we can take a look. I guess we can open it up and see what's wrong with it. All right, we are in, and I think this is brand new. There's not a speck of dust. I don't think this has been used at all. It's literally brand new. It's a simple amplifier, but I think I like it. It's got discrete transistors here. I'll show you in a minute. It doesn't have one of those integrated crappy things. And I think there is a little bit of electronic here on the front panel. I think there's some logic, probably the logic dealing with the input selection and this kind of error controls that we've seen. This is where voltage is coming in, and this is the main transformer. So obviously we have some standby voltage generation, because we have a light at the front panel and we have some logic intervening. So I guess mains is coming here, and I believe we have schematics. We'll have a look in a minute, but I have a feeling that this is going to be this is a regular transformer, probably doing some sort of standby voltage, and you won't be able to see it from there. But on this connector, which is going to the front panel, it says 5 volts, but then it says 3.3 volts S. I guess it's for standby, and I'm assuming that we have that 3.3 volts standby. Then when I'm pushing on, or when I'm resetting the protection at the front panel, the logic is turning on this relay. The relay is sending mains voltage to the main power supply, and the main power supply is outputting with, I would say, 3 outputs. We have these main chunky cables here, the yellow and red ones, and these are the main voltages, the main rails going for, I don't know, plus 50, minus 50 volts, something like that, for the sound generation. And then we have some more. We have some yellow here, yellow and blue, AC probably going to the same power board. Then we have blue and black going on the right hand side of the board. It doesn't really say. And I think there's something else. No, that was it. I'm hoping that the transformer is working, because if the transformer is not working, well, that's gonna be a dead end, I have a feeling. Well, number one, I really like the PCB. It's showing quite a lot of information. I'm used to the Onkyo ones. They're very, very cryptic. Like, for example, this component here, I don't know if you can see that, not only says IC91, so you can see that, you can find it on the service manual, but there's also the name, the part number, printed on the PCB, so that helps a lot, because sometimes the part number is not clear or readable on the component itself. And I had a look online. This one, it's voltage regulator, and the same is for the other one here. This is a 5 volts regulator. It says 278R05 or 78805, basically, just with a different name. So that's the 7805 for 5 volts, I guess. And this, I don't know, it might be a regulator for 3.3 volts. We'll have a look. Actually, it ends with 3.3. So I'm assuming that that's the 3.3 volts generation. All of these jumpers on the PCB, it says what kind of voltage I'm expecting, so I can probe around. But we also have the service manual, so we're not blind here. We're not shooting in the dark. So I would say, before we start digging into the service manual, I really would like to take some quick measurements here, see what seems to be happening and what seems not to be happening. Got the multimeter out, let's power up, and again, this is going to be in its standby faulty state. 3, 2, 1, go. Okay, yeah, I have the red light flashing. Do we have 3.3 volts output? We do, so we do have 3.3 volts standby. Do we have 5 volts? I don't think we're going to have it. No, I think this is going to be only happening when it tries to power on. I honestly feel that 3.3 volts is all we are getting when this unit is in standby. So I think the next step is to try and power it up by disabling the protection and see whether we are getting 5 volts and whether we are getting, most importantly, something on these AC lines, which are then going to the rest of the amplifier. So I'll disable the protection now. We do have 5 volts, happy days, and then it goes back into protection. Okay, so we have 5 volts. Now I think I'd like to see if we have any AC going here. And we do. We have 30 volts on this leg, and let's see on the other one. We have 30 something volts AC on both legs, so this seems to be okay. This is also AC. I see there's a black wire, and then we have two oranges. This might be for the 5 volts generation. 10 volts on one leg and 10 volts on the other one, so that looks to be okay. I don't know, 10 volts AC for 5 volts generation, it feels a bit too much, but I'm assuming that's okay. We'll check, of course. Let me see what we are getting out of these blue and black wires. Does it say anything there? No, but again, we'll check on the service manual. But that should be another AC. It's coming out of a transformer, so it should be another AC voltage. Yeah, we're reading 13.5 on one leg and the same on the other one. So I would say this is good news, which means the power supply seems to be working without looking at the service manual. I don't see anything obviously missing. I think at this point is when I have to spend a few minutes on the service manual, trying to understand how the voltages are working. Most importantly, whether on the service manual there's any mention on how the power protection works. What is the power protection looking for? What could trigger the power protection error? Before we continue, a quick shout to the sponsor of this video, PCBWay, a leading PCB manufacturer based in China. Whether you've designed your own PCB or you have found a project online that requires a PCB, well, PCBWay is your stop. PCBWay can manufacture what you need with a very high quality. The system is very much automatic. All you need is the Gerber file of the project of your choice, upload it on PCBWay.com, and just select a postal service and PCBWay will deliver the PCBs at your place. And PCBWay is not just PCB manufacturing, it's also 3D printing, metal sheet fabrication and CNC machining. Take a look at this 3D print that I ordered for my collection of vintage CPUs. It looks absolutely amazing, the quality is absolutely outstanding. I thoroughly recommend PCBWay for the quality of the products and the customer service, so take a look at PCBWay.com and let me thank PCBWay for sponsoring my videos on my channels, because their help makes these videos possible. So thank you very much, PCBWay. Now let's continue with this Pioneer amplifier. I might have found something. Here on the right hand side there's a connector with some wires going to the front panel where the volume control is. No, that's a volume control. I see some coaxial cables and it says front out right, front out left. So this is where sound is actually being commuted, I guess. But the last two wires are plus 15 VA and minus 15 VA. For any electronics working with sound, needs to have plus and minus something to actually generate sound. Now, if I'm checking plus 15 VA and I'm disabling the protection now, I'm reading 15 volts and that's what I'm expecting, and this is going back into protection. But if I'm reading minus 15 VA and I'm once again turning off the protection now, it's not reading anything. And I have a feeling that the electronics is definitely looking for that plus and 15 volts to be there. If it's not there, I guess you can end up with all sort of distortion on the outputs. So I guess if plus and minus 15 is not there, that's it, that's a power fault and the unit is going to be in protection mode. Let's have a look on the service manual where that minus 15 volts is coming from. Right, I had a look at the manual, I really like it, it's just the on-cue manuals I really dislike. Now, first thing first, we have an overall connection diagram here. It's amazing. You can see you have the mains coming here, got the connector, then we have another connector going to the main transformer, and you see those three set of wires. One is going here, one is going here, one is going on the second page, which is here, which matches what we've been seeing here. We have three sets of cables, one is going there, one is going here, and one is going there. I mean, it's a great help. When you're trying to understand how this thing works, it's definitely good help. Then on this page you can see this is where mains is coming. We have this little sub-transformer, as I thought it's just a linear transformer, it's not a switch in one, which is generating the 3.3 volt standby going to the MCU, the microcontroller unit. And then we have the main transformer, which is driven by the main relay, which is driven by the power on signal coming from the MCU when you push the on-off button at the front. And these, we have three rails coming out. One is the chunky wires going for the amplification of the sound with B plus and B minus. Then we have this one for plus 5 volts for the LEDs and volume, I don't know, the volume control or volume board. Then we have our plus 15 and minus 15. Obviously, this is how it's called, like center tap. So we have rectification, a couple of capacitors, and plus 15 and minus 15. And I have a feeling, we'll check in a sec on the service manual, but I have a feeling that we are talking about this cable here, which is going here, and we have two capacitors, and we have a couple of ICs in here. This might be one for the plus 15 and one for the minus 15. Now this is the actual schematics, is where mains is coming in through the plug, and then it connects to the board to connector 96, which is here on the left hand side. It's going into the standby transformer, but then is going through connector 93 to the main transformer, and from the main transformer we have those three wires that we were talking about, and we have one for B plus and B minus, the main always that plus 30 and minus 30. Then we have this one for the 5 volts generation, it's a bit on the small side, sorry, 5 volts generation, but then we have connector 91, which is generated plus 15 VA and minus 15 VA. And it's very simple. We got AC coming in, we got some rectification and some capacitors, but most importantly, then we have two, I think these are linear voltage regulators, I'll check in a minute. And then we have minus 15 and plus 15, plus extra diodes and some extra capacitors. So it doesn't make sense that we have plus 15, but we don't have minus 15, unless I was measuring wrong. I would say let's try and go and measure straight at those components, and we see what comes in, what comes out. Okay, this is where my AC for plus and minus 15 volts is coming, and then we have some diodes and some small capacitors, then we have these voltage regulators, and then we have two big capacitors, and that's it. And I don't know if you can see that on camera, but the PCB says IGO, so that should be input, output, ground. I mean, this is so, it makes repairing this thing so simple. Kudos to Pioneer. I mean, I'm used to Onkyo, repairing Onkyo stuff. It's a disaster. This is actually a pleasure. So we already know that we have some AC coming through this connector now, and we know that we have plus 15. So this is the plus 15. Let me see if I can measure the plus 15 volts output of this component here, which happens to be a 7815, and the other one is a 7915. So these are linear voltage regulators. Nothing can go wrong here. Okay, I'm going to disable the protection now. Yeah, we got 15 volts here, and protection comes back. And let's see whether we are getting any minus 15 volts out of this one. 3, 2, 1, go. We don't. That is the fault, 100%. That's 100% the fault. But we do have output from the power supply, so I'm optimistic here. Might be about soldering at the back. Do we have an input? Now it's going to be interesting to measure without shorting everything. Let me see what I can do. I'm touching the input pin leg actually of the 7915, so I'm supposed to see some negative voltage, I guess, not zero. Yes. So is the 7915 faulty? It's ground connected. Let's take the 7815 as a reference, so ground should beep. Yeah, it does beep. Do we have ground on the 7915? We do. Well, then, unless there is a short somewhere, and that is why the voltage is going down. This is where probably the thermal camera would be helpful, because I would see the 7915 glowing red, and that would tell me that either there's an issue with the 7915, it's still possible, or more likely that something else is collapsing the minus 15 volts somewhere on the PCB. Let me get the thermal camera out. Yes, well, obviously my 7915 is getting scorching hot. So does that mean that the 7915 is faulty, or something is drawing so much power the 7918 can't cope with it? I guess I can unplug this connector here. I haven't checked on the schematics, but this is where at least some of the minus 15 volts is going to the front panel. So if I unplug this connector here, which you can barely see, I'm sorry, I should be able to find out whether, well, at least the minus 15 volts come back to life. If it comes back to life, well, we have a problem somewhere else. If it doesn't come back to life, it might mean that the 7915 is faulty. Let me unplug it. No. Okay, well, that could be good news. It could mean that the 7915 is faulty. Let's check on the schematics whether the minus 15 volts is going anywhere else. Right, things are getting a bit complicated because I see some components at the back of the board, and unfortunately there is no inspection, how would I call it, hatch at the bottom. It's unfortunate because I will have to basically remove everything from the chassis and recompose everything on my working mat in here, and because I will have to turn it on. But before I get to that, I found that this connector here, this cable here, which is going to this board here, which is connected to the tone control, bass, treble, and balance, also uses plus and minus 15 volts. So I'm going to disconnect this cable here and see if by any chance I'm reading a voltage, a minus 15 volts voltage. That would really help. Nope. Okay, so it is something else, unfortunately. Let me just do a quick pass with my thermal camera, see if by any chance I can find something obvious at the top of the board. You can see the CD7915 glowing and the respective diodes. Why would the diode? I don't know, I might need to take a look at that. But the thing is, I don't see anything else. That is super hot. There's really nothing scorching hot on the rest of the board, at least not on this side. Let me try and turn it on again while looking somewhere else. No, I mean, there's something there coming up, but it's nothing compared. As soon as I put the 7915 in the frame, it's nothing compared to that. And if the 7915 is getting so hot, I'm assuming that there would be something else scorching hot. Now, what if I'm overthinking all of this? Let's go back to the basics before I go too deep into that. We have some diodes before the 7815 and 7915. So if I'm checking the diodes before the 7815, which we know is working, I'm reading, well, it's reading negative, probably there's something from a capacitor, some voltage from a capacitor, but now it's reading 0.5 something. If I'm reading the other one, it's reading the same. And if I'm reading in diode mode of the input of the 7815, again, I'm reading this negative stuff, but then I'm reading something. The output is reading something, fair enough. Let's do the same test on the components of the 7915, the minus 15 volts. So if I'm checking on the diodes, 0.013 doesn't move, it doesn't go anywhere. And then I have 0.013, it doesn't go anywhere. And what am I reading between ground and the input of the 7915? So that shouldn't have anything to do with what happens afterwards. If there's something shorted after the 7915, well, I don't think with a multimeter you would read anything on the input. But if I'm checking the input, well, it's reading a short. Is that, well, that's in diode mode. What do I read in resistance mode? I'm reading 12 on the input. I have a feeling that 7915 is toasted. And the diodes, I didn't realize the diodes that were glowing are before the 7915. So obviously if the 7915 is shorted, well, these diodes are doing the rectification for the 7915 for the supply of the 7915. So obviously they're glowing. Before getting crazy, just remove the board, remove the 7915, test it, and see if by any chance that's our problem. This is the back of the board, this is the 7915. I see a little bit of brownish around the center pin here of the 7915. I think it's just the lacquer that they sprayed on the PCB as protection. It just got a bit warm. But yeah, I don't see anything wrong. There are some components here at the back of the board which I couldn't see through the grill, and these are a couple of diodes I've been looking for because they're in the schematics. I couldn't find them at the front, and I thought the schematics were wrong, but no, they're here at the back. And once again, look how nicely this PCB is done. It shows you where the connector is coming. It shows you have two diodes here. You have capacitors, diodes, capacitors, electrolytic capacitors. This is the positive, this is the negative. I mean, this is the the back of the board. And it helps a lot. You can actually see the jumper links, these white things. So you have for example, the plus and minus 15 volts, they end up here. And then they jump through these jumper links here. They follow these lines, these traces, then they jump here. I mean, it makes repairing these things so much simpler. Enough me talking, shall we remove that 7915 and test it on the bench? And it's indeed shorted. I think, a short between ground and input, if I'm seeing this right. Yeah, it's reading 12 ohms. That's what I was reading on circuit. Now, okay, let me show you something. I've noticed something that I didn't see that before. We could see actually on the thermal camera. This is a shorted, burnt voltage regulator. It has a hole in it, and I could see that on the thermal camera, but I thought it was just the way it overheats when something is shorted after the 7915. So no, this is cracked. There's a crack in the middle, it's shorted internally, and that's our fault, ladies and gentlemen. I found the 7915 CP, and before I install it, well, let's make sure it's not shorted. So we do have a short between the ground and in. Yeah, and what about this one? Well, no, of course. And what are we reading here? Oh, we're reading nothing. That's interesting. What are we reading here? Wait, we have a short here? Oh, it's shorted on these capacitor pins. Okay, panic over. There we go. No, it's not reading anything anyways. Anyways, we don't have a short. Well, let's install it and test this thing. I'm really curious. And there is no short anymore. Yeah, short is gone.
The short is gone.
So I guess I can partially reassemble it. I think I don't want to reassemble it fully. Now, this was the only connector in the amplifier which had a broken clip on it, and this happens to be the AC connector that eventually generates the 15 plus or minus 15 volts. So I have a feeling that these went back to a service center maybe, and you know, service centers these days, especially official ones, they don't actually do component repairs. They unplugged this cable, the thing came back to life, they said, okay, you need a new motherboard. And it was quoted probably silly money, and it was like, no, I don't want it. I don't want to pay for it, just return it to me. That probably explains the return and repair tag on the box. Right, I think I've reassembled everything I'm ready to test, but we have to consider one possibility, and that is that there might be a short somewhere on the board, and the 7915 failed because of that short. So yes, I can test it, and if it works, happy days, but I will turn it off immediately, and then I'll get the thermal camera out again and make sure that that 7915 is not getting scorching hot. And then we'll move from there. Mains voltage now. And let's disable the protection now. Yes. Yeah. Yes, it's working. Right, let's turn it off. You know, I'm always overcautious when it comes to those things. Let's turn on the thermal camera, double check that that is working. It's not overheating, and if it's not overheating, we fixed it. Yeah. Thermal camera on, let's turn on. 3, 2, 1, go. We got minus 15 volts, and yeah, no, thermal regulators are lukewarm, both of them. So the top one is there you go, they're getting 30 degrees, but yeah, the same temperatures. And the minus 15 volts, which is the one at the bottom, this one, is not hotter than the other one. Amazing! They're both around 36 degrees, and actually the 7815 is warmer than the 7915. So there is definitely no issue. It was definitely an issue with the component. The component shortened internally and it died. And I have a feeling, I don't want to say that this came out of the factory like this, but This thing is unused, but it seems to be working. Shall we plug a speaker and see if we actually get sound out of it? This is fully up and running. I'm so happy. It's working! It's working amazing. Let's try the other channel. It's working as well. Let's check these controls at the front. And balance is also working. Let's check the loudness control. That is working, and then we have a direct, which is basically bypassing all the circuitry, all the tone controls and everything for purity. That seems also to be working. Let's check the input selection. Yeah, well, I should really check each one of these inputs, but it seems to be working fine. Perfect. Well, this thing is working. It was just a linear voltage regulator. Kind of unusual. I wouldn't expect that to fail unless there's something else shorted after the voltage regulator. Then the voltage regulator overheats all the time and eventually fails. But it's kind of weird. I don't think it's a common issue. But again, anything can happen, of course. Let me put all the screws back. This is fully working, but we haven't finished yet. I'd like to check the bias of each channel. There is a procedure on the manual to check that, and then I'd like to do a power test, make sure that this unit goes to, I think it's like 30 or 50 watts maximum power, and then I think it's done. The process to adjust the idle current or the bias or the offset, I think it is, it's pretty simple. I mean, it shouldn't be required, but it's on my desk, why not? It should really be required if you replace the motherboard or some of the components circled in this red square which are affecting the bias or the idle current. And the adjustment is pretty easy. Turn on the power supply of the product. Turn on the power supply of the product. What does that mean? Turn on the product. Anyways, give power to the product, to the amplifier, set input selector to SACD-CD and the volume to minimum and wait 3 minutes. Connect the multimeter to, we have connector 31 and 32, I'll show you in a sec. And then we adjust 2 trim pots so the DC level becomes 8 millivolts plus or minus 2 millivolts. So these are the 2 connectors. I plugged something that I can easily use with my multimeter, and that's it. I mean, the bias level, the offset level will vary with temperature. That's why it says turn it on and wait 3 minutes. Let me plug the multimeter, we'll power on, wait 3 minutes and do the adjustment if needed. Okay, I'm wired, as the manual says, I have no speakers, I'm on CD input and the volume is at minimum, and as soon as I power up, this is reading, ignore the fact that it's the other way around, it's reading 6.7 millivolts, and we are looking for 8 plus or minus 2, so this is pretty good. Let's give it 3 minutes and we will see where it gets. And 3 minutes have passed, I have 9.5, which is within tolerance, but you know me, I'm gonna touch it. I'm just curious to see how sensitive it is, so let me see what happens if I'm turning this trim pot. Yeah, it's very, very sensitive, but I think, let me just move it a bit back and forth. There we go. And then let's go back to 8. Right, I got 8.3. We'll check the other channel while this channel stabilizes and see if it stays there or if it moves a bit. Well, the other channel is spot on at 8 millivolts. So obviously I don't need to touch this one. Let's go back to the other channel and yeah, let's make sure it's reading 8-ish. Well, now I'm thinking about it. I'm wondering whether this is actually wildly incorrect. Because yeah, I said ignore the negative. But when I moved the connector to the other one, it was reading plus 8. Well, let me double check the other one real quick, and I'll make sure that I got the black lead on the left. Yeah, this is reading 8. And I think the polarity of the connectors here is exactly the same. I don't think this is right. But then I find a bit weird that out of the box, one is reading 8 and one is reading -8. The manual doesn't say anything. It just says, make sure you're registering 8. It doesn't really say which is plus, which is minus. Now, if I look at those adjustment trim pods, they're actually mounted the other way around, opposite to each other. They're rotated. So maybe this is normal. The whole circuit is specular, even though the connector has an arrow pointing to the right-hand side pin on both of them. Now, I don't want to break this, but I think I can go up to plus 8.1 here. No. No, I cannot. So, no, I can't go up to plus. So this has to be this way. And I think it's just the polarity is swapped between channels. It kind of makes sense. Am I doing this right? I mean, if you know this better, please do leave a comment down below. I'm ready for the power test, and I've got here my little dummy load. This time is 8 ohm resistor. I'm using this one and this one. All the other ones are unused because this unit at 8 ohms, it's only supposed to output 30 watts. So these are 100 watts with a heatsink. Again, I'm gonna do this short term, so it's gonna be totally fine. I've got both channels wired to the oscilloscope, and I checked before I wired my oscilloscope that the negative of the output of the amplifier is actually grounded. You can't keep that for granted. And when you are plugging your ground lead, or negative lead if you want to call it that way, to the load, you are actually grounding the negative output of the amplifier. So you want to make sure that it's grounded by itself. I've got some statistics here running, and right now I have 2 volts per division. I might need to increase it a bit. I'm feeding 1 kilohertz to the unit, and what I'm looking for is when the 1 kilohertz gets clipped. And that means that's the maximum power that this unit can deliver to the outputs. The oscilloscope should be keeping track of the maximum for all the peak-to-peak RMS of both channels, so you know we can take a look. And if I turn up the volume a bit, yes, I do have a little something coming up. Let's see if I can clip it with this resolution. No, I might need to increase it a bit. There we go. Now we have 5 volts per division. Still not enough. 10 volts per division. That's it. There is where it clips. And we have a maximum of 58, 59 volts between left and right channels, peak to peak, and 21 point something volts RMS. Well, if I'm using the Ohm's law correctly, this seems to be 60 watts, not 30. So I'm not entirely sure whether I'm doing something wrong with the calculations here, or the datasheet is wrong, or this is better than it's supposed to be. Now, this is the service manual, and the service manual says the A10 can deliver 30 watts at 8 ohms and 50 at 4 ohms. But I didn't notice something. It says both channels driven 20 to 20 kilohertz. And that is a much wider test of the spectrum for an amplifier. So the 1 kilohertz test is usually much higher, but it doesn't really represent the real world situation. When you're playing music, you're not playing a 1 kilohertz tone. You're playing the whole thing from 20 to 20 kilohertz. So this is a much more conservative power figure. So if I'm doing 30 watts at 20 to 20 kilohertz, I'm not surprised that this thing can do twice as much at just 1 kilohertz. So I don't know, I think I'm happy with this. Both channels are equal in level. I don't see issues, distortions, and I got plenty of power at 1 kilohertz. So I guess this is it. This is done. I'll close it and keep it on for a while, test it with some music myself, and then I guess I'll find another home for it. Now, I work in the cinema industry where professional sound equipment is being used, and when it comes to professional stuff, there is no marketing in it, or very little, as the speaker has, or the amplifier has to perform, has to deliver that amount of watts, has to deliver that amount of sensitivity, that amount of frequency response, etc. It's not Wonderland, but that's how it usually works in the pro industry. Now, when it comes to consumer devices, I have to say that unfortunately there is quite a lot of marketing surrounding these things, and this is the brochure, the data sheet of this very amplifier, and along with all the features of this thing, I see this anti-standing wave insulator. Those are the feet of the unit, they're plastic things, okay, plastic feet, normal feet. The anti-standing wave insulator features a special foam with no parallel sides inside to prevent cavity resonance. This makes the sound localization tone and scale clearer, while also contributing to seamless connection between the channels and improved response to quick sound. Just a plastic foot with no parallel surfaces inside is making the sound clearer. This makes me laugh so much. I mean, there is a little bit of physics behind what they say, but I don't really think it's something that you can hear, especially on a unit like this. This is a basic unit, it's a budget unit, and plastic feet with non-parallel surfaces inside is not going to change absolutely anything. But I have to say that that doesn't seem to be just marketing. Pioneer seem to actually believe that, because this is a service manual. And he's telling you that when some things are disassembled, there are some sound quality improvement tape pieces to be put back where they belong, because they make the sound better. These are the feet of the unit, and apparently when you put them back, there's a little dot that needs to be aimed at a specific direction. It's not random, and this is to improve the sound. Inside, if you remove the volume knob, there's two pieces of tape inside which are supposed to make the sound better. There is also a piece of tape on the side of the volume knob, I can see that from here, and that's also apparently there to improve the sound quality. I mean, how can a piece of tape on a volume knob improve the sound significantly to a point where you can actually hear it? I mean, I know that some people will disagree with me. Feel free to leave a comment down below. Maybe on a very, very, very high-end expensive unit, then that might be the last 20% and you try and squeeze everything out of it. But this unit is very basic. It's got no name components on it. All the capacitors are like very cheap brand from what I can see. What do you think about it? Leave a comment down below. Let's hope that we don't make a massive conversation about it. But as long as it's polite and civilized, I welcome that. Well, it's working totally fine. I tested it for a little while and it's just working. After all, it was pretty obvious that the fault was a bad voltage regulator, I guess. I don't want to say from the factory, but probably shortly after this unit was produced. It was a cool fault. It's simple but not simple, as you still have to do a little bit of troubleshooting. It's not just the usual, you open the unit, oh that's it, that's the blown capacitor, I replace it and happy days. Yeah, you have to look at the schematics, look at the voltages and try to understand what happened. I hope you enjoyed the video. If you did, as usual, I'd appreciate the thumb up down below, and also consider subscribing to this channel and my other channel if you like this kind of things. Don't forget I'm on Facebook and Patreon, and the links are down below in the description. There is a free tier on Patreon, so no excuses, but if you don't want to support me on Patreon, which is very much understandable, well, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, I fully understand and appreciate your time. I hope you had fun. That's it for today. Thank you for watching, and I hope to see you soon here on my channels for my next videos. Thank you very much, and goodbye. Bye bye.